For decades, we've defined software engineering by the act of writing code, but the human effort in software delivery is rapidly migrating away from the middle of the pipeline. The engineer is no longer valued as a mere typist of syntax. We are moving from the traditional software development lifecycle to an agentic development lifecycle, where the implementation layer is completely autonomous. This chart maps the engineering role transformation. The left side, writing syntax, is no longer the primary value driver. Code generation is handled by agents. The right side represents our future, defining what to build and verifying it. The practitioner is now the architect of intent. Think of modern AI platforms as compilers. A traditional compiler takes precisely defined source code and outputs machine binaries. An intent compiler takes precisely defined human specifications and outputs production-ready software. The human engineer composes the melody, the business logic, and the required outcomes. The AI agents supply the notes, the exact syntax and boilerplate required to make the system run. Mastering this craft means letting go of the execution phase. Your focus belongs exclusively at the absolute edges of the software pipeline, the input and the output. If the codebase is now autonomously generated and maintained, the true intellectual property resides in how we define our input. This diagram is the intent compiler model. It maps the end-to-end flow from human intent through an autonomous platform to validated software. Look at the left side, the input edge. This is where human control is established before any code is generated. Informal, conversational prompting often fails completely in complex enterprise environments. Agents require rigid mathematical constraints to succeed, not just open-ended suggestions. To provide constraints, the specification stack translates human intent into machine instructions. Layer 1, strategic intent, connects decisions to outcomes. Layer 2, behavioral specification, defines explicit edge cases. Layer 3, context engineering, curates architectural knowledge. Layers 4 and 5 dictate operational boundaries and evaluation. These 5 layers of engineered context, not the generated codebase, are the most valuable assets a company owns. Returning to the compiler model, we move to the center, the autonomous platform. This is the engine executing the work. The architect of intent does not dictate how multiple AI agents collaborate. Whether the workload requires a hierarchical, sequential, or competitive pattern, the platform orchestrates that internally based on the task. The core mechanism driving this platform is the plan, execute, verify, or PEV loop, replacing the traditional pull request cycle. When verification fails, it doesn't wait for developers. The failure triggers automatic AI replanning at machine speed, requiring zero human intervention. This chart illustrates how an engineer controls this black box. You do not manage tasks or review code. You set rigid operational boundaries. These expectations fall into 4 pillars: quality gates, behavioral contracts, resource boundaries like compute limits, and strict governance policies. Your role is expectation setting and constraint enforcement. You define the rules, the machine executes the labor. Finally, we arrive at the far right of the model, the output edge. This is where we address the core anxiety of deploying AI tools. That core anxiety is trusting output you didn't create yourself and trying to navigate an expanding, tangled web of unverified, machine-generated complexity. Evaluation-driven development shifts focus from testing code to validating the intent that generates it. This cycle shows how EDD reorganizes the workflow. You design the exact evaluation criteria before defining your intent. By evaluating output continuously against a predefined standard, ambiguous requirements are exposed immediately. The feedback loop drops from sprints to mere seconds. Traditional unit tests verify isolated functions. In EDD, we use a golden data set, curated inputs mapped directly to verified outputs. It performs holistic verification, checking canonical happy paths, pushing limits with boundary cases, and deploying adversarial scenarios to break the system. Golden data sets are the mechanism of control. They are the only way to mathematically guarantee that the autonomous platform fulfilled your strategic business intent. Recent studies by Metra revealed a jarring data point. Experienced developers using AI assistants were actually 19% slower when working on familiar codebases. This happens because of the senior tax. Highly skilled engineers devolve into Castilians. wasting their expertise reviewing, correcting, and polishing messy AI-generated output. The AI productivity paradox exists because the industry is still measuring output, like lines of code, instead of measuring value. High coding velocity means nothing if the evaluation pass rate is low. That just generates technical debt at machine speed. What matters now is the intent fulfillment rate and the cost per validated feature. In an autonomous pipeline, generating code is a liability and a cost. Validating a completed feature is the only true value. This shift presents a systemic challenge known as the junior developer cliff. If AI handles all the routine coding tasks, how do junior engineers ever develop the deep understanding needed to become architects? The path forward involves an apprenticeship model, where juniors learn by building inside the specification stack, not the codebase. They begin with context engineering and golden datasets. By defining the evaluation criteria, they learn exactly what correct system behavior looks like before they are ever asked to define a high-level architecture. We are witnessing the final phase of the transition from coder to conductor. A conductor doesn't play every instrument. Their mastery lies in observing the whole, maintaining the strict boundaries of the tempo, and guiding an ensemble of autonomous virtuosos to the exact desired outcome. The engineer's value has transitioned to a higher level of abstraction. Success now depends on the rigorous precision of human intent, rather than the mastery of a specific programming language.